purpose of the who am I command, just as the name suggests, is to get the username of the currently logged on user. So I'm just going to be doing it practically. So I'm going to type it in right here. Who am I? Hit enter, and as you can see, I get the username of the currently logged on user, which is this one. The next command is the who command, and the who command basically displays information about the users who are currently logged in. So sometimes you're logged in as user A, and then you signed out of that user and you logged in as user B. So, or let's say, for instance, you have connected to a remote system and you would like to get information about the users that are logged into that system. So you just type in the who command. And as you can see, in my case, there's just one user that is logged in, and we get some more information. So this number right here, colon and 0, indicates the display number. So in my case, I only have one display or one monitor, and counting in computers starts from 0. So I'm going to have the 0 value here, same as here. And then you are going to get the date and the time when the user logged in. The next command is users, which is almost the same as the who command, but this one displays just a list of the currently logged on user. So while the who command provides some more information, such as the login time and the display number, the users command will just give us a list. So if I type in users, we just get, the usernames. So if we had more than one username logged on to this system, then we just get user A, and then on a new line, user 2, user B, user 3, and on and on. The other command is the add user and user add command. So I hope you guys can see a trend even from yesterday. Most of these commands, by just looking at the command itself, you're able to tell or to have a rough idea of what the command does or how it works. So for instance, who am I? That's a question. That's who am I is a statement you can use even in normal English, in just regular English if you want to know your identity or something like that. So the add user command here, as the name suggests again, is a command that enables us to create a new user or to add a new user entry to the system. So in my case, for instance, if I want to add a new user, maybe for a friend or someone else that I would like to give access to my machine, all I need to do is type in the add user command and hit enter. Okay, so it says only root may add a user or group to the system. So the process of adding a new user to the system is considered by the underlying Linux system as a process that affects the underlying system, and so it is a process that requires more higher privileges, what we call root privileges in Linux, and on Windows that would typically be admin privileges. So to execute a command with root privileges, we simply prepend it with the word sudo. So sudo followed by the command that we want to execute, in this case, add user. And if we hit enter, we'll be prompted to provide our root password. Okay, so only one or two names allowed. So we are supposed to type in sudo add user followed by the username right here. I'm not going to do that, but you already have an idea of how that works. And then we have the user add command. So both of them do the same thing. They allow us to add a new user to the system, but they have a very subtle difference. So the add user command is sort of like a wrapper or a more customized version of the user add command. So the user add command is actually a script. There's a scripting language called Perl. Let me type it right here. Perl. Let me even open the source code of the Linux kernel so that you can see where it comes in. So if you look at the languages that are used in writing the Linux kernel, you can see, of course, C is the dominant language. We have some assembly for the bootloader, shell, makefile for compilation, some Python, and then we have Perl. So Perl is a scripting language, just like Python, Ruby, and the likes. Only that Perl was there several years ago, so it's a bit old, a bit outdated, but it's still a part of the Linux kernel. And the user add command, this one, the second one, is a Perl script that does the entire work of adding a new user entry to the system. So as you might expect, not every user might be experienced in interacting with Perl scripts, because it requires a lot of parameters. And so what they have done is they have added another command on top of it called the add user command now, that allows us to add a new user by simply just typing in sudo add user followed by the username. But in the case of the user add command, we will be required to do other things like specify the kind of shell. We will touch on the shell later on. You're expected to specify the shell in this case and also the home directory for the new user that you want to add. Then other command for managing users is the password command. Password in shortened form in this case, we don't have the O and R letters. And typing in the password command on the command line will prompt us to change the user password of the currently logged on user. So if you, for instance, right now we are logged in as this user right here. If we want to change his password, we can just type in password, PASSWD, hit enter, and it will prompt you for your current password. Let me do it on Kali. I'm not sure. Okay, I don't have it running. Let me just, okay, I have it running. Let me just log into my Kali Linux machine and do that right here. So who am I? In this case, we are logged in as the user Kali. So I'm going to type in password, and it will prompt me first for my current password. The default is Kali. And then I'll be required to provide a new password. So let me just type in Kali123, again Kali123. And as you can see, password has been updated successfully. So the next time I restart my machine, or even if I log out and then try to log in again, I cannot use the old password, but I'll be required to provide the new password. The other command for managing users is, okay, not really managing users, but another command associated with users is the sudo command, which we've already touched on. Let me move here. So if you can remember, we said the add user command, or any command really that makes significant changes to the underlying system, like adding a new user entry, it will require higher privileges. And for us to execute a command with higher privileges, we need to prepend it with this word, sudo. And sudo is basically short for super user do. So we are basically telling the root user, on Windows, that would be the admin user, to execute the following command. So for instance, on Windows, if you want to install an application that requires admin privileges, you'll not just double click on it. You'll instead right click and then select run as administrator. So the equivalent of that on the Linux command line is prepending the command with the word sudo. So I hope that is clear. Are there any questions so far regarding managing users before we move on to the next group of commands? If we are cool up until that point, you can just show me that with a thumbs up. Okay, Lincoln, you can ask your question.
Yeah, I was asking concerning the mode in which, say, I'm in root or hii ya kawaida. Does it matter when I'm installing anything, the permissions and stuff? Say I want to install a software, an app or something. Does the mode admin matter? The privileges and stuff inaingiliana, inaweza affect?
Okay, one of the core differences between Linux and Windows is the permissions enforcement. So Linux is a bit more strict when it comes to permissions. And so by default, you are not able to do anything. And by anything, I mean things like adding users, as we have looked at right now, even installing applications and all that. So even if we want to install a new application via the command line, Linux will deny us the permission to do that unless we prepend it with the sudo command. So basically, we need to be root in order to execute such commands that have a significant impact on the underlying system. I hope that is clear.
Oh yeah, I get.
So actually, in the next slide, I'm not sure if it's the immediate next one or in the next few slides, we will look at how to manage software from the command line. And you'll notice that all the commands that we shall be executing will start with this one, because we need to be root or to have higher privileges in order to install any applications. Any other questions? Okay, I think we are all cool. So let us move on to the next set of commands. So the next set of commands is for software and package management, just as I have mentioned. And by software or package management, I mean the ability to install and install, update, or even upgrade existing or new applications or packages on our system. Now, for us to be able to do that, we have a set of different commands that are available to us based or rather depending on the system or Linux distribution that we are on. So we have the apt-get command, we also have the yum command, and the dnf command. Now, all these three commands, however different, all do the same thing, but they are the equivalent of each other on different kinds of Linux distributions. So if you are here on day one, we looked at the different kinds of Linux distributions that we have out there. For instance, Ubuntu, Fedora, Kali Linux, Parrot, etc. And out of all those distributions, or in all those distributions, we have some other categorizations whereby we have some distributions that belong to the Debian category. Let me just type that out, Debian. And we have another group of Linux distributions that belong to the Red Hat category. So in the case of Debian distributions, Ubuntu is a Debian distribution, Kali Linux is a Debian distribution as well. In the case of Debian based or Linux distributions that are in the Debian category, we use the apt-get command to perform all the software or package management operations. And in the case of the other category, which is the Red Hat category, examples of operating systems in Red Hat are CentOS. We have RHEL, that is Red Hat Enterprise Linux, which they charge for. And then we have others like Fedora, etc. So all these are under the Red Hat category. So in the case of Red Hat-based Linux distributions, the equivalent of apt-get is now either yum or dnf. So yum was used in older versions of Red Hat-based Linux distributions, and in modern ones, we have the dnf command instead of the yum command. So all of them basically do the same thing, but based on the kind of Linux distribution that you are on, you might have access to this one or one of these. So since I am on Ubuntu, which is under the Debian category, the only command that I have access to is the apt-get command. Now, the first thing that we can do is to install a new software package. And by the way, by a software package, when we say that we are installing a software package, what we add to the system is the binary or the actual executable, which is what we will be running. For instance, the Firefox binary. And some other things that are included in the package are things like the documentation. If you were here yesterday, for instance, you must have seen us use the man command a lot, which is short for manual pages. So the software package, a good software package comes with the binary and also the documentation of the manual pages and any other dependencies or any other programs that the main binary requires in order to work as expected. So to do, let me just try doing it practically. So again, this is a command that modifies the underlying system. So we need to start with sudo, which is short for super user do again, and then apt-get install, followed by the name of the package that you want to install. So yesterday, one of us had asked about the difference between Emacs, Nano, V, and Vim. And I typed in Emacs, for instance, and we didn't have it. As you can see, command Emacs not found, but it can be installed with all these commands. So by the way, besides apt-get, I think apt is a shorter version of apt-get. So apt and apt-get, I think, are more or less the same thing. I've never tried them out in different cases to see if they work the same, but the fact that they have listed it right here instead of apt-get means they do the same thing. So to install Emacs, since we do not have it, the command for that will be sudo apt-get install Emacs. I hit enter. Now, the reason it has not prompted me for the password here is because I had just a few minutes ago executed another command with high user privileges, and Linux is smart enough to save, that password that I provided somewhere in memory for a few more minutes, or I don't know the span of time that it's saved in memory, such that when we choose to execute a command with higher privileges again, we will not have to retype the same, we will not have to retype our password. So the packages are automatically installed and are no longer required but then you are told after this operation, 146 MBs of additional disk space will be used. I'm not ready to do that. So if you're interested in installing it, of course, you can go ahead and press Y for yes. I'm going to just press no because I don't want to install it. And if you press yes, of course, it will go to the internet automatically, download it and install it on your system. And once the command completes its execution successfully, you'll be able to now type in Emacs and you'll be able to have access to the actual Emacs command line tool. The next one is apt-get update. So of course, these applications are maintained. Any application or software out there has its own life cycle. So there is the inception phase where we have the idea. There is the development where we move from the idea to the actual code, and then we build it into a binary. And then once we've gotten at that point, we start focusing on maintaining the binary, introducing new updates or new features, and fixing any bugs or vulnerabilities that may be discovered. So if we want to update or rather to upgrade our software or our program to the latest version, the first thing that we do is to update the local package index. So a bit on the local package index. In your Linux system, any Linux-based system, somewhere, I can't actually remember the path where we have those files, there's always a file which is what we're calling the local package index. And what that file contains is a list of all the applications that you have installed and the version number. Okay, so if you want to upgrade to a newer version, the first step is to update the version numbers in that local file that contains the list of installed applications. Now, what this command does behind the scenes is that it will read the local file that you have on your machine and pick the version numbers that you have, and then it will go online and look at the version numbers that are available. Now, if the version that is available on the internet is more recent or higher than the version that you have on your local machine, it will then update the local file on your local machine with a newer version. After that, you can now proceed to execute the apt-get upgrade command, which will now go through the packages that you have on your system. You can actually optionally specify the package name after this. So you can run it, you can do sudo apt-get upgrade. You can optionally provide a package name if you want to upgrade just a specific package and not every one of them. Or if you want to just upgrade every package that you have on your system, you can just leave it at that. And if you hit enter now, what this command will do is that it will go to that file on your local system, the local package index, and then proceed to, if the version numbers have been updated, if they are newer than the actual versions of the packages that you have installed, it will now go on the internet and get the more updated versions of the binaries. So I hope that is clear. So to upgrade any applications that you have to a more recent version, you start with sudo apt-get update, which will update the local package index, and then you proceed to do apt-get upgrade, which will actually upgrade the packages. The other command of interest is the apt-get disk upgrade. So these two commands are more or less similar, but this one is what it does its work intelligently, quote unquote. So both of them upgrade the installed packages, but this one does it intelligently. Now, so let me explain what I mean by intelligently. I mentioned right here that when we install a package, it is not just a single file that is added to our system. Rather, we have the binary, which is the executable, and then we have other things like its documentation and other dependencies. Dependencies are other files which might be executables or not, which are required by the main binary in order for it to do what it's supposed to do properly. So when we do apt-get upgrade, what it will do is that it will just upgrade the binary itself. I should have written it more correctly right here. It will upgrade the binary itself, but it will not stress over the dependencies, which are what are actually required for smooth functioning or smooth operation of the main binary. If you use apt-get disk upgrade, it is smart enough to also look at the dependencies, and if they too need to be upgraded, it will automatically upgrade them without us having to do that manually. So if you ask me, I'd recommend you go with apt-get disk upgrade instead of this, because this one is smart enough to go beyond the main binary alone, and it will look at the dependencies that the main binary depends on, and it will also upgrade them as appropriate. The other thing that you may want to do is uninstall or to remove a package from our system. So say, for instance, I am tired with Telegram. Maybe I just want to get rid of Telegram desktop. So to remove it, I'll just type in sudo apt-get remove followed by the name of the package, or I can do sudo apt-get purge followed by the package name. So again, just as these two commands are more or less similar or related, these two commands are also more or less similar or related, only that they have a small subtle difference. So in the case of apt-get remove, it will remove the package, but it will retain what we call the configuration files. So a nice example for this is Visual Studio Code, or any IDE for those of you that have done some programming or still do some programming. Once you install something like an integrated development environment, you'll oftentimes find that you have the option of customizing some things. For instance, even Visual Studio Code itself, you'll find that you have the option somewhere in its settings to change the theme. You can have a light theme, which is a white background, or you can have a dark theme, which is where you have a dark background. So when you install the application, of course, it will come with the default. I think it's a light theme. But then, say, for instance, you change that to the dark theme, the application will need to save that information in what we call the config files. Config is short for configuration files, so that every other time you open the application, it will know to not go to the default, but to rather use the configuration or settings that you as the user have set. So if you use the apt-get remove command, it will just remove the package, but retain those configuration files. Now, the benefit of this is if you choose to reinstall this package again in future, you'll not have to again go through the pain of customizing it, because it retained the configuration files or the custom settings that you had set for that particular application. However, the apt-get purge command will remove both the package and the config files. So purge removes everything essentially. So if you are made up that you do not need that application entirely, and even its configuration files, you can just type in sudo apt-get purge followed by the package name, and it will remove every single trace of the package on your system. The other one is apt-cache search. I don't know if this is cache or cache. And this command allows you to search for a package name in the online package database. So again, not every binary is available for installation via the command line. For instance, if I want to install, I don't know, maybe even Telegram desktop, I didn't install this using apt-get. I used another one called Snap. So if you want to confirm whether a particular application exists for installation via the apt-get command line tool, you can simply start by searching for it in an online database. So you need to be connected to the internet, and then you can simply type in, let me do that, apt-cache search followed by the name, let's say, for instance, Telegram. If I hit enter, actually we have it. So we have some interesting packages that are available. So we have the Telegram API library. That's not what we want. Another API library, voice over IP library, command line tool. So it seems we do not have Telegram desktop available on, available for installation via the apt-get command line tool. So that's the use of the apt-cache tool, apt-cache command line tool, in that we are able to confirm whether or not a package that you want to install is actually available for installation via the apt-get command. The final command for software or package management that we are going to look at is the apt-get do release upgrade, which allows us to upgrade to a newer distribution release. So we have already looked at how to upgrade existing packages or software applications within our system. Suppose now we want to upgrade our kernel. Yesterday we used the uname command, which allows us to get system information, and using the R switch gives us the release version. So this is the Linux kernel version that I have on my system. And if we look at the GitHub repo for the project, you can see they are already at version 6.9. So say, for instance, I now want to not just upgrade, this application, Visual Studio Code, Firefox, Telegram desktop, etc., but I want to upgrade this kernel to the latest one, which is 6.9. So maybe I have gotten some GPU for my machine, and I hear that in the latest Linux kernel version, they have great support for multi-threading or something like that. The command to do that, to actually upgrade the underlying system, is apt-get do release upgrade. And beyond upgrading the Linux kernel, what it will also do is that it will upgrade the distribution itself. So I am on Ubuntu 20.04, I believe it's an LTS, but I think the latest LTS or the latest long-term support version of the Ubuntu operating system is 22.04, if I'm not wrong. So if I want to upgrade to that as well, this command will do just that. So again, if I execute the apt-get do release upgrade, it will start by checking whether there is a new version, in my case, of Ubuntu. So if there is a newer version, in my case, of course, there is a newer version, that is Ubuntu 22 or even Ubuntu 23. And then it will proceed to start the process of upgrading all my existing system files and libraries to the newer version of the operating system. And if the newer version, for instance, Ubuntu 23, uses also a more recent version of the Linux kernel, like 6.9, it will also upgrade the kernel underneath, which is the heart of the operating system, so that it can also get to Linux 6.9. That is it for the software and package management commands. And again, I'm going to give you an opportunity to ask any questions or seek any clarifications that you may want regarding that. Okay, if you have understood everything in that section, please show me with a thumbs up. All right, so let us move on to the next set of commands. And that is networking operations. So for you to have an easy time going through the networking commands, you may want to have some prior experience or some little background knowledge on computer networking. So a computer network, simply put, is a group of one or more computers or computerized devices that are able to communicate together and exchange information. So again, a computer network is a collection of two or more computers or digital devices that are able to communicate or exchange information or maybe even share files. So some of the commands that you can use to perform network operations, one of them is the ping command. This is very simple and available on just about any system out there. So the ping command is used to check for network connectivity. So all you need to do is type in ping, followed by either the domain name that you want to test for, that you want to see whether we can reach, or the IP address that you want to see whether we can reach. So if I want to, for instance, check whether I have internet access at the moment, all I need to do is type in ping, followed by a domain name, for instance, google.com. And as you can see, I start, first of all, it says ping google.com. It maps that to the IP address for the closest Google server to me. And then we start receiving bytes from that server. So what ping does underneath is that it sends a number of packets to the particular either domain name or IP address that we have specified right here, and then it listens for a response. So if it receives a response back, then that simply means that you've been able to reach that particular domain name or that particular server. And if we are not able to receive that response, then that simply means that we are unable to get in touch with that server. So if I were, for instance, not connected to the internet and I typed in ping google.com, then what I would get here is something like network unreachable. I believe that's the statement I would have gotten back. And so if you are on a network event, this is not limited to testing internet connectivity. If you are on a network and you have some nodes, a node is just a device in a network. If you have some different nodes set up on a network and you want to test whether or not communication can be done between these different nodes, then all you need to do is open the command line on one of the systems and type in ping, followed by the IP address, for instance, 192.168.100.35 or .137. So an IP address, again, for those of you that may not have prior experience or maybe have those of you that have not learned about networking before, it is a unique identifier for every device or any device that is connected to a network. So even in, for instance, a bank or a secure building, you might see those CCTV cameras which are monitoring the movement of people from up there. Those CCTV cameras are connected to a system somewhere where the people are able to watch what is actually happening or watch the footage from the cameras. Since those cameras are connected to a network, they too have a unique identifier, and that is what we call an IP address. The same thing goes for your phone. Whenever you connect to a wireless network using your phone gets assigned a unique identifier, which again is the IP address. So every single device, even on the internet, that is any device that is connected to any network, it must have a unique identifier, and that is what we call the IP address. So the other networking command that we need to be aware of is the ifconfig command. And what this does is that it displays and it allows us to display and configure different network interfaces that we have on our system. Examples of network interfaces are, your wireless card or an external wireless antenna if you have that, and even the Ethernet adapter. So if we type in the ifconfig command, let me just type it in. ifconfig, and as you can see, we get a lot of output. So the first part of all these small sections represents the interface name. So one of them is Docker 0. Docker is a containerization technology. I'm not going to touch on that. This is NP3S0. This is my Ethernet adapter. The name for that, as you can see, Ether. And then we have LO. LO, this one represents the loopback address. So the loopback address is a special address. As you can see, it has the same syntax as an IP address, but this one allows the machine to communicate with itself. So if you're, for instance, doing some personal project and you have started the server and you want to access your website locally and you're still running it locally, then all you need to do is open your browser and type in this address, and the request will be routed back to the host machine or the machine that sent that request, which is the same machine that you are on. And the final interface that I have is the WL01, and it contains an IP address because, again, I'm connected to a wireless network. So this one is the wireless adapter in my case, and that is it. That is the basic functionality of the ifconfig command. Of course, we can do other things like configuring them. If we, for instance, want to turn off or disable this interface, we can, let us just type in man again for the manual pages of the ifconfig command. And as you can see, we have a lot of information about it. So it allows us to configure a network interface. So ifconfig is used to configure the kernel resident network interfaces. It is used at boot time to set up interfaces. So note that. And after that, it is used usually only needed when debugging or when system tuning is needed. If no arguments are given, just as you have done, ifconfig will display the status of the currently active interfaces. If a single interface argument is given, then it will display the status for that particular interface. So we can, for instance, do ifconfig, and then maybe just focus on this one. Hit enter, and as you can see, we get the information for just the Ethernet adapter. And that's it for the ifconfig command. Of course, there's a lot of other customizations and a lot of other things that you can achieve with it, but I'm going to leave that to you because all the documentation, all the usage instructions are available via the manual pages. And the next command is the net start command. Start here is short for statistics and net is short for network. So the net start command allows us to basically view the network statistics. It allows us to display network connections, routing tables, and interface statistics. So again, let us just try it out. So type in net start. And as you can see, we get active internet. Let me go back to the top. We get active internet connections. So look at any computer in the networking context. You can look at any computer or any node, any device connected to a network as a building that has a door, has several windows, and several other points of entry. So in the same manner, just as the building has several different points of entry and exit, every computer has different openings, so to speak, through which traffic can enter or leave the machine. Now, those openings, in quotes, are called ports, And the net start command will list all the active ports or all the ports that are actively being used, and it will give us its status. We can use it to see the status of the ports, whether or not they are open. We are also able to see any connections that are active on our machine. So if, for instance, we have some program which is running behind the scenes and it has connected to some remote server by using the net start command, and maybe if we provide some additional switches, I hope you can remember the idea of switches and command line arguments, then maybe we are able to customize our output so that instead of receiving all this information, we are able to maybe, for instance, view all the outbound connections or view all the inbound connections, etc. The other one is SSH. SSH is short for Secure Shell. And again, in network balance, SSH is a protocol that allows us to connect and interact with a remote machine over the command line. So again, we said one of the reasons why it is good for us to be familiar with the command line is it is not all the times that we will have access to the graphical user interface of a remote computer. Sometimes the only thing we will have access to is the command line, and that is where SSH comes in. So to connect to a remote machine via the command line, all we need to do is to use the SSH command line tool. So I'm going to clear this, type in SSH, and the format for it is the username of the remote machine. So username, let me just remove these ones, SSH, username, we use the symbol, followed by the IP address of that remote machine. And once we hit enter, we will be, if the username is correct and if that IP address can be reached, we will then be prompted to provide the password for that specific user. And then we will be able to interact with the remote machine as though we are logged in physically at that machine. So I'm going to try that out. I'm not sure if my Kali Linux machine is already running. It's already running. So let me open it and see whether I will be able to connect from my Kali Linux machine to my host Ubuntu machine over SSH so that you can see it in action. Oh, we changed the password. So you can remember we changed the password. So the default one, which is Kali, is not working. You see your password is incorrect. So let me type the new one, Kali123, hit enter, and we are successfully logged in. So the first thing I'm going to do is confirm whether or not I am able to reach my host machine, which is my Ubuntu machine, from my Kali machine. And I'd like to request one of us to give me the command that I can use for that. Okay, Alvin, please ask your question first. Alvin, I can see you've raised up your hand.
Yeah, sorry about that. I wanted to ask, in the command ifconfig, you've said it's used to show interfaces. I was asking, is there an interface that allows for communication between your virtual machine and host
I can't
machine?
hear you clearly. Come again. Please come again.
Okay, I'm asking in the context of the ifconfig command. So you've said it's used to display network interfaces. So my question is there an interface that allows for communication between a virtual machine and the host machine?
Yeah. So if you want to connect your virtual machine and your host machine, which is what I actually did before this session, simply go to your virtualization software. In my case, that is VirtualBox. Select the virtual machine, then click on the settings button at the top here.
Your audio is a bit low.
Okay, how about now?
It's still quite, it's inaudible.
And the rest of you guys can hear me? Not yet. Anyone that can hear me can show me with a thumbs up. Can you guys hear me?
Okay, we can hear you, but you sound quite distant. You're not
Don't know
that
why. Okay, how about now?
Yeah, much better.
Okay, I think it's my microphone that had faced another direction. So as I was saying, you just go to VirtualBox, select the virtual machine whose network settings you want to adjust. And then here you will have a tab for network and you'll be able to change it right here. So we have a number of options. One is NAT, short for network address translation. We have bridged adapter, internal network. So this is basically where you can do all that. So in my case, because I wanted to be able to access my host machine from my virtual machine and vice versa, I used a bridged adapter. You can look that up. I'm not going to go into details of this because we are just focusing on the command line for now. And then once you select that, you'll be able to select the interface. Since I'm over a wireless network, I selected the wireless interface. And once you hit OK, the settings will be saved and you'll be able to do whatever network operation you want. So I hope that answers your question.
Yeah, I'm okay now.
Okay, okay. Yeah, so I was asking you the command that we can use to check whether or not we can reach our host machine from the virtual machine. And I can see Joy has answered that. Thank you, Joy, you are correct. It is the ping command. So all you need to do is get the IP address of our host machine. So let me delete this. I'm going to do ifconfig, hit enter, and then you are going to grab this address right here. This is the IP address. I'm going to copy it, and then I'm going to come to my Kali Linux virtual machine, and I'm going to type in ping followed by that address. Then I'm going to hit enter. And as you can see, I get back the bytes that are being sent to my host machine, which means we are able to actually reach that host machine. So the next thing is to try out our SSH command. Again, the syntax for that is SSH followed by the user. So we all know that the username here is this one, namesxt. So I'm going to copy that as well, get back to my virtual machine. I'm going to paste that at, and then the IP address was 192.168. Let me check, .43.14.43.14. Hit enter. Since you're doing it for the first time, are you sure you want to continue connecting? Let's type in yes. And then it will ask us for the password of that user on the remote system. So I'm going to type in my password on Ubuntu, hit enter. And if it is correct, we should drop inside the shell for the host machine. So let's give it some time. And as you can see, guys, let me just clear the terminal. As you can see, we are no longer in the Kali Linux terminal. We are no longer at the Kali at Kali. We are instead at namesxt at AlphaX, which, as you can see right here, let me adjust the size of this. As you can see right here, is pretty much the same as what we have on our host machine. The username is namesxt and the host name is AlphaX. So that is how you use SSH to connect from one machine to another over the network. So to terminate the now from here, by the way, you can do anything you want. So it's like I am on the host machine physically. So I can, for instance, navigate to the desktop. I don't know why it's slow to respond. It's not picking my keyboard input. I don't know why. Let us just leave it at that. Or let me just try to exit, and I don't know why it's not doing it. I hope you guys can hear me. Please confirm that you can hear me. Okay, okay, thank you. So it's not any issue with network connectivity. So let me just leave it at that. But in case you are, once you get access to a remote machine via SSH, you can basically do all you want. Oh, it says the network connection has been disconnected. So I guess it's a disconnect between the virtual machine and my host machine. So okay, I think we can now do it. Okay, we can now do it. So if I type in pwd to get our current working directory, we can see that we are in the home directory of this user, namesxt. I can navigate to the desktop, for instance. If I do ls, as you can see, we have the list of files on the desktop. I can navigate even to the intro to Linux directory. If you do a listing, we can see the files. So you can basically do anything that we want this in the same manner that someone else who has physical access to this machine can do. So that is the benefit of SSH. Once you're done doing whatever it is that you are doing and you'd like to terminate the connection, you just type in exit and the connection will be closed. As you can see, connection to the IP address is closed. So that is how you use SSH to connect to a remote machine. The other command is SCP. And the reason I have placed it immediately after SSH is because it works on top of the SSH protocol. Again, it says SSH is a protocol that allows us to connect with and interact with a remote machine over the network, over the command line, sorry. And the SCP is a command line tool that allows us to securely copy files between different machines via SSH, okay? So yesterday we looked at the CP command, which allows us to copy a file from source location to the destination. So suppose we want to copy a file, yes, but not within one machine, but rather between two different machines that are connected over a network. In that case, rather than using the CP command, we are going to use an extended version of it, which is called the SCP command. By the way, the S in SCP represents secure, so secure copy. And it allows us to copy files either from our local machine to a remote machine or from a remote machine to our local machine. So I'm going to do that right now. So I'm going to go back to my Kali Linux machine. And what I'm going to do is try and copy a file from a remote machine, which in this case will be my host machine, onto my Kali Linux machine. So I'm going to go to the desktop so that you can see it when it appears here to confirm that the transfer will have been successful. And to do that, we simply type in SCP. Again, it is just an extension of the copy command. So the syntax is the same: SCP, the source of the file that you want to copy, and then the destination. So in this case, the source is a remote machine. And so what we are going to do before providing the path of the file on this remote machine, so the file that I want us to copy from my Ubuntu machine is sensitive company document, which is just created for this purpose. It's actually an empty file, as you can see. It's an empty file, but I just created it for the use in this demonstration. So we type in SCP, but then before we provide the full path to this file, we need to authenticate and actually specify the IP address of the machine from which we want to get that file. So just as with SSH, we are going to start by specifying the username of that remote machine, and then we are going to specify the IP address, so username @ and then the IP address, which was 192.168. Let me check again. .43.14. Hit enter. .43, sorry. .14. And then once you have specified the username and the IP address, you're going to have a colon, and then we can now provide the path to the file which we want to copy. So in our case, we want to copy the, let me clear this. In our case, we want to copy this document, sensitive company document.pdf, and you're going to provide the full path to that document. So home, followed by the username, which is namesxt. We are in the desk. We want to get the file from the desktop, and the name of the file is sensitive. Let me just copy it like that. And then so this is the source. This is how we point to the source if you're copying it from a remote machine. And then the final value or the final command line argument is where we want it copied. We just want it to appear on the desktop. So I'm going to use a dot so that it appears in our current directory, and I'm going to hit enter. It is going to prompt us for a password because we are doing this over SSH. So I'm going to type in my password. And as you can see, guys, sensitive company document 100%. And if you look at our desktop, a new entry appears, which is the document that we had in our Ubuntu machine. So that is getting a file from a remote machine to our local machine. So let's look at the opposite of it. So say, for instance, we are some attackers, and you've been able to find the password for this user on the remote machine, and now we want to deliver a file called malware. Of course, it's an empty file. Again, I just created it for illustration purposes, So I'm going to type in SCP again, and can anyone guess what the syntax will be this time round? Can anyone? Let me copy this one so that you can be free to edit it if you want. So anyone with an idea of how we are going to type out the SCP command now that we want to transfer the file not from a remote machine to ours, but now from our local machine, which is Kali Linux, to another machine, which is the host, Ubuntu. Anyone with a rough idea of how we'll do that? You can raise up your hand if you want to just speak it out or guide me through the process. Okay, if you don't know, laugh at yourself using a laughing emoji. Okay, so you guys know. So Felista, okay, you guys are laughing at yourselves. Okay, so you don't. Oh, you've typed it. Let me take a look. Okay, yeah, actually you are correct. So SCP, the source, which is the actual file in this case, and then the username, the IP address of the remote machine, and the full path. So let us try it out. I'm just going to copy it as is. And then I'm going to come to the terminal here. I'm going to paste it. And I'm going to hit enter. Yeah, so we are prompted for a password. Let me provide the password. I hope it is correct. Okay, I typed in the password incorrectly. Yeah, as you can see, we get malware 100%. So let's go back to our Ubuntu machine and do a listing of files in the desktop. And as you can see, guys, we've been able to successfully copy a file now, this time round, from our local machine to our host Ubuntu machine. So thanks for that, Alvin. You can clap for him, guys. Let me clap for him. Where's the clapping emoji? Can't see it here. Yeah, thank you. Thanks for that, Alvin, once again. So that is the SCP command for you guys. You'll be required to use it a lot when you get to a point where you are constantly interacting with remote servers. So if you're, for instance, in a DevOps role, sometimes even in a software engineering role, you might want to transfer some file or some script to a remote server, and this command will save you with that because again, it is the files are copied over a secure connection. Rachel, I can see you've raised up your hand. Go ahead.
Hi. So I was asking, can you explain more on the host machine and the remote machine?
Okay.
Like
so,
detailed explanation. Thank you.
Okay. Okay. So in this context, the host machine is the machine that is directly running on bare metal. The host machine is the machine that you log into every time you restart your machine or every time you power on your machine. That is what we call the host machine. The virtual machine is an instance of another operating system that we have installed and are using on top of a virtualization software like VirtualBox or VMware. So I don't know if that explains it. And then on remote machine and local machine is what we are currently interacting with as, as the actual user. So if we are physically seated at a computer, for instance, and using it, that is our local machine. A remote machine is a machine that is in, ideally in some other remote location. But since we are using, we already have two machines on my computer right here, we can just as well call one the host machine, which is the one running on bare metal, and another one the virtual machine, which is Kali Linux. And then in the case of maybe or in the case of copying files using the SCP command line tool, the machine on which we are executing that command is called the local machine, and the machine to which we want to copy the file or from which we want to copy the file is called the remote machine. I don't know if that explains it.
Yeah, that's okay. Thank you.
You're welcome. Atieno, what is the host machine? What if the host machine is Windows and the virtual machine is Kali Linux? Yeah, I think it should work because we have executed this from Kali Linux. So if you do it from your virtual machine, which is Kali Linux, it should work. Feel free to try it out. And if you want to execute the commands from your Windows machine, I don't know if Windows has the SCP command line utility. If it doesn't, feel free to check out something called WSL, which is what allows you to sort of use a Linux operating system as an application, quote unquote, within your Windows machine. Okay, you're welcome. Any other question? What if a machine doesn't have a password? What will one enter when requested to enter a password? You'll just press enter. It's called, we call that anonymous logins. And it's actually, it actually comes across as a vulnerability because you see, if you have some server that you have purchased somewhere or set up somewhere on the internet and you forget or you remove the SSH password, then trust you me, in a matter of minutes, your machine will be compromised because the internet is a rough place, and at any point in time, there is what we call bots, which are automated scripts and machines that are usually just created and released into the internet by people. And these are bots, or which are scripts, are always scanning ranges of IP addresses, looking for such obvious vulnerabilities. Is WSL better or more secure than using a VM? I don't know about that. I've not used WSL a lot, and I've not looked into it a lot, so I'm not in a position to say whether it's better or more secure than using a VM. Maybe better because then you won't have to go to the pains of installing a VM. I think maybe that's okay. Any other one? Yeah, the command for accessing the IP address on Windows is ipconfig. That's right. If you are on Windows and you are following along, the equivalent of ifconfig on Windows is ipconfig. Thank you for that, Ambrose. If you're all okay and I can move on, show me with a thumbs up. Morris, can I be able to see devices connected to the same network as mine on Ubuntu? Yes, you can do that. So in networking, we have something called, is it ARP? The Address Resolution Protocol. And the Address Resolution Protocol is what is responsible for mapping between IP addresses and MAC addresses. So if you are communicating with other devices on the network, what happens is your machine sends out an app request. Again, that is more into networking. So maybe you can take your time after the session and look more into it. But what happens is your machine sends out a request called an app request, and it is broadcasted, or broadcast more correctly, to all other devices in the network. And whichever device has that IP address, it will respond back with its IP and MAC address. And these two, the IP address and MAC address, are then added to what you call an app table. That is the Address Resolution Protocol table, which can be available on your machine. And so by listing down the app table, you'll then be able to see details of other machines that are on the same network as yours. So that is tools that have been developed for that specific purpose. So they leverage the ARP protocol to scan for any other devices on the network. Since we have Kali Linux machine right here, I can look for it. I don't know if you guys can see app, you can tell me. Let me just type it right here. Okay, it seems it doesn't come by default. We actually, as you can see, if you just type in ARP on our Kali Linux machine, because we have already connected with the other machine on our network, as you can see, we are able to see the IP address of the other machine. This is the IP address of my host machine, and its hardware address and its MAC address. And this is the IP address of our host, which is Kali, and its MAC address. So I hope that answers your question. So what you do is you use the ARP protocol. You can look it up after the session to learn more about it. Okay, I'm receiving an issue and trying to ping the google.com server using the domain name. What could be the issue? I think that's an issue with DNS. but please allow me to continue so that you don't get stuck here. So please feel free to look it up, Ambrose. It could be an issue with your DNS files, or maybe you are not, your connectivity is not as strong for your request to go through. Can I see the devices connected to the same network? Yes, I hope I've answered your question, Maurice. You just use the ARP protocol, that is Address Resolution Protocol. If you guys are okay, just show me with a thumbs up once again. Okay, so Ambrose, you seem to have a deeper problem. So maybe you can get in touch after the session. I don't know if you are on the WhatsApp groups. Maybe once you are done with all the slides, you can get back to this. You can remind me then. So let's move on to the next set of commands. Actually, the next command, we have another one that you've not touched, which is the wget command. So the wget command allows us to download files from the internet. So again, that's another beauty of the command, that we are able to do just about anything and everything, including downloading files. So to download a file from the internet, all you need to do is type in wget followed by the URL to the file. Now, by file here, I mean an image, a document, a complete web page, etc. It could even be a binary or an application that is hosted somewhere. So I have a URL that I saved for illustrations purposes. So I'm just going to come right here. It's a picture of Alvin. So I'm just going to copy this URL. And I'm going to get to the command line and I'm going to paste it. So if we look at our desktop, by the way, we do not have any image right here. But then if I execute wget followed by the URL to that image and I hit enter, as you can see, we have all these log things that are logged right here. We connect to that remote URL and then we download it and we save it. And as you can see, we get a new file on our desktop, which if I open, is a picture of Alvin. So that's how you download files. So for any other file that you want, just type in wget followed by the URL, hit enter, and that file will be downloaded to your machine. So let me I just opened it for that purpose so that I could copy the URL and use it to demonstrate the usage of the wget command. So on to the next set of commands, managing processes. So a process, by definition, in the context of operating systems, is a running instance of a program. So for instance, in this case, I have Firefox web browser running, I have the terminal running, VirtualBox, my Kali VM, and the document viewer. So all these, as they are running, are now called processes. And we might want to do a lot of things on processes. One of the obvious things is to see a list of running processes. Another thing is to maybe get real-time information. So let us start with the first command, which is the PS command, short for process. By executing the PS command, PS, we are able to get a list of commands. But again, as you can see, we get a very limited output. Of course, at first glance, you can just see we have Firefox running, terminal, VirtualBox. So we'd expect our output to have all these listed. And so if we are not able to see that, then that means there's something else that we are missing right here. So maybe there's a switch or a command line argument that we are supposed to add in order to get more information. So again, back to the manual pages. If you ever get stuck using any command, just type in man followed by the name of the command, and you'll be able to get all the usage you need, all the usage information you need. So PS reports a snapshot of the current processes. So it displays information about a selection of the active processes. We have some more information. Let's go to the examples. So to see every process on the system using standard syntax, you can type in PS-E. So let us try that out. PS-E. And as you can see, when we do that, we get a lot of more information as compared to the previous case. So let us look for something like Firefox, for example. If you guys can see it, you can save that. I don't know if it's here. Okay, we have VirtualBox, for instance. We have the terminal. So as you can see, they are listed here. We have Firefox, yeah. So using the -E switch, we are able to get more information about the processes that are running. We have Redis server, we have Tor, we have Postgres, which is the database. We have FreshClam, which is an antivirus for Linux, Docker, etc. So I'm going to clear that, and that's it for the PS command. We get a listing of running processes, but again, it is just a snapshot of running processes, not real-time information on the running processes. If we want to get real-time information on the running processes, we use the top command. So the top command allows us to display dynamic, so it keeps changing real-time information about running processes. So let us try it out. Top. And as you can see, the appearance changes of my terminal window. And we get, as you can see, these the order of processes here keeps changing. The values keep changing. Right now we have isolated webcore at the top. As you can see, these values are changing. The time changes. The amount of memory consumed, the percentage of CPU used by that process, virtual memory, etc. So as you can see, the values are constantly changing. And that is what we mean by real-time information of the running processes. So you might want to use this if you're, for example, monitoring a specific process. So if you want to see whether a particular malware gets triggered at a particular time or when certain conditions are met, you can just execute the top command and just keep looking at this list. And once the new process is created, you'll see a new entry pop up right here. So to exit this, I'm just going to press Q and it stops. You can clear the terminal and move on to the next one, which is the kill command. So these are pretty scary and direct command. But what it basically does is it allows us to send what we call a signal to a process. And the default signal that you can send to a process, a signal is just like a message, just as you can text someone or speak to someone and tell them, go, come, stop, do this, do that. If you want to issue those such instructions to a process, we use the kill command. And the default command or the default signal, if we do not specify any, is what we call sigterm. So sig, let me type it right here. So the first three letters are short for signal, and term right here is short for terminate. So by default, if we type in kill, followed by a process identifier, what you call the PID, if we do not specify this kind of signal we want to send to it, by default, the process will be terminated because, again, the default signal or message that is sent to that process is for it to terminate. If you want to customize, the message or signal that we send to the process, you can just type in man kill and you'll get more information. So as you can see, the usage is kill, options, and then followed by the PID. The PID, by the way, is a unique numeric identifier for each running process on our system. We'll go back to our top or the PS-E to see the PID column. So as you can see, the default signal for kill is term, which again is short for terminate. I don't know if they have a list of, okay, they don't have a list of all the possible signals that you can send. Let me see if you're able to list that. Okay, yeah, we can use the L or -L to list available signals. So let's do that, kill -L. And as you can see, all these are the different signals that you can send to a process. Sig HUP, sig int, interrupt, sig quit, we want to quit gracefully, sig pipe, sig cont, sig stop, etc., etc. So all these different signals mean different things. You might want to take your time and go deeper into them. These are handy if you are into something like systems programming, building things like kernel drivers and other things like Linux kernel modules. That is where these come in handy. But for now, if you're just interacting with processes, most of the times, all you need to do is to terminate the process, and the command for that is kill space followed by the PID. Now onto the PID, if you do PS-E again, and you move to the very top, you can see we have some columns. We have the PID, TTY, the time, and the command. So the PID column is what's of interest to us now. And as I've said earlier, it is a unique numeric identifier for each running process on the system. So if we want to issue a signal or an instruction to a specific process, we will need to know its PID or process identifier so that the signal can be sent specifically to that process. The other command is kill all, which is related to the kill command, only that rather than being required to provide the process identifier, we are at liberty to now provide the name of the process. So again, getting the process identifier might be a longer process as compared to remembering the name. For instance, right now I know Firefox is running. Of course, the name of the process is Firefox. So if I don't want to go through the pain of doing ps-e and then looking for Firefox, grabbing the PID and then using the kill command, I can just do kill all, and then provide the name Firefox. I'm not going to hit enter because if I hit enter, I'm going to, of course, disconnect from the meeting because that is what I'm using to speak to you guys. But if I want to close something like calculator, let me open calculator. Okay, and then I'm going to do a listing of the processes to see if we have a calculator there. I can grep. Remember, grep is used to filter. So I can just do grep. Okay, we can't see. Let me just do ps-e, see if it appears right here. I don't know if we have it. GNOME calculator. Can anyone see it? If you can see it, just speak out and tell me you can see it.
I think it's at the bottom.
Yeah. Let me do it again. Yeah, so it's here. Thank you. That's GNOME calculator. I don't know why it's missing the R. So if you want to kill this specific process, again, we can just do kill and then provide the PID, which in this case is 2197. I hope this is the correct one. I hope there isn't any other command that has this name. So 2197, hit enter. And as you can see, our calculator stops running, it closes. So we do not have calculator amongst the running processes. Let us open it again, and this time try killing it using the kill all command so that we'll just provide the name. So I'm going to clear this, do PSA. We have the name right here. So let me copy the name instead and use the kill all command. Kill all, hit enter, and again, it closes. So those are the two main ways of sending signals to a process. The reason it is just closing by default, again, is because if we do not specify a custom signal or instruction to send to it, the default behavior is for the process to be terminated or killed. The other command is pgrep and pkill. So pgrep is sort of like a merger between the ps command and the grep command, in that we are able to display information about the running processes, but we have the option to provide, some filters, quote unquote, which in this case are, for example, filtering by name and some other attributes like the user who initiated that process. So if we want to, for example, see all the processes running under the user namesxt, which is my username, hit enter, we get a list of process IDs. Again, by the way, the output of the pgrep command is just process identifiers, not process ID, the process name, etc. All we get are the PIDs. So if we want to, for example, look for a certain process, let me open, for example, GNOME calculator. We have already learned from the previous commands that the name for this process is GNOME calculator. So if we hit enter, okay, I don't know why we're getting an error. Let's go back here. So pgrep user that. I don't know if we, let me just remove that and see if we can get that. Yeah, so in pgrep, we're able to specify the user whose process list we want to focus on, and then we can optionally provide a name for the process that we want to look for. And if the process exists, we directly get the process identifier. So I hope you understand that. And the other one is called the pkill command, which is closely related to this one as well, in that we are able to do what we are able to do with the kill command, only that we have the additional option of filtering, again, based on certain criteria. This could be by the process name, just as in the pgrep command, or even other attributes like the username, or the user whose process list you want to focus on. So I can do, for example, pkill. Let me open calculator, it's running. So I'm going to do pkill, and then I'm going to just filter GNOME calculator, hit enter, and as you can see, it closes. So yeah, in this case, we've been able to filter using the name. If we do pkill and then user namesxt, and I forget to include a specific name for the process that we want to kill, if I hit enter, it will by default terminate all the processes that are running under this user. Of course, I'm not going to do that because it will disconnect me even from the session that we are having, because it will also terminate the Firefox process. But I hope you understand that. And the next thing that you're going to look at is permissions. But before that, I'm going to give us an opportunity to ask any questions or seek any clarifications from that section. You can raise up your hand. Okay, if you are cool, just do a thumbs up so that we can proceed. Okay, thank you. So let us move on to permissions. Let me remove this from my favorites. I no longer need it. Let's go back to permissions. So again, from the one, we looked at some of the core differences between Linux and Windows. And one of them is that on Linux, there is a stronger permission enforcement as compared to on Windows. So permissions, simply put, dictate who can read, that is the first thing, who can write, and thirdly, who can execute files and directories on the system. So they are divided into three sets. So before even moving on, I'd like to do a long listing. So I'm going to do ls-l. The L switch here means we want to get a long listing of the files in the current directory. So as you can see, besides the file names and the date of last modification, the file size, the username, and the group, we have some other information at the start right here. So this is what you're going to focus on for this section on permissions. So the first character here indicates the type of file that we are dealing with. So if it is a single dash, then it is just a regular file. If it is a letter D, it is a directory like Intro to Linux and Kali Linux. And of course, the terminal goes and does an extra step of highlighting these files using different colors. So for instance, the ones in blue are directories, the ones in white are regular files. If it is an archive, it is in red. You know, if it is a D here, it's a directory. If it's a single dash, it's a regular file. And then there is another one where you will see an L. So if it is an L, then that file is what we call a link. And a link is basically the Linux equivalent of Windows shortcut files. So on Windows, we have the option of creating shortcuts, but on Linux, we call those symbolic links. And if we had a shortcut on our desktop, then that file could have been listed here with an L at the start. After that, we now have this set of characters right here, which are what indicate the permissions that are attached to this particular file. So let us focus on this one. For example, we have three sets, by the way. So we have 3, 3, and 3, okay? So the first set of permissions are for the owner of that particular file or for the current user of that particular file, program, or directory. And the second set of permissions, which are the next 3 characters, are the set of permissions for the group of users. In Linux, we have the option of creating user groups. So these are the set of permissions for a user group associated with that file or directory. And the final set of permissions are the permissions for any other users on the system. So this one is for users, denoted by the letter U. So the first set is for user, denoted by the letter U. The second set is for the group of users associated with that file, denoted by the letter G. And finally, we have others, which are for any other users on the system, which is denoted by the letter O. Now, onto the specifics, each set can have 0 or all of 0, 1, or all of these permissions. And these permissions are read, write, and execute. So I'd like us to look at each one of them individually. So the read permission, if we have the read permission to a file, we are free to view the contents of that particular file or directory. If we have the write permission, denoted by a small w, we are able to allow, rather modify the contents of the file or directory. And if we have the execute permission, denoted by the letter X, we are able to execute that particular file if it is a program or script. So the underlying system, before we can proceed to start playing around with the permissions, I'd like us to understand how the underlying operating system handles it. So computers understand only one language, and that is binary. ones and zeros. And so even these file permissions that we see right here, read, write, and execute, at the very bottom, behind the scenes, they are represented by switches, which can either be on or off. So if the user, if we, for instance, in this case, we have read and write permissions for the user or owner of the file, then the switch for read will be on, that will be a 1. The switch for write will be on, so that will be another 1. And the switch for execute, it will be turned off because we don't have that permission. So it will be a 0, and the result for that will be 1, 1, 0. So this is a binary. This is a binary number. And if you are familiar with number systems, then you should know how to convert a binary to a decimal, because that is what we, the humans, are more familiar with. So to convert this to a decimal, all you need to do, binary is to the base of 2. So 2 to power 0 times 0, that is 0. So if it's just a 0, we are going to ignore that. If you get to this, you just do 2 to power 1, that is 2. And then if you go to the leftmost digit, that is 2 to power 2, which is 4. And then we add this and we get 6. So if you want to represent the permissions for the owner of this particular file that we have right here, we as the users are going to provide the value 6 on the command line. So I have some examples right here. In the case where someone has all the 3 permissions to a file, that is read, write, and execute, we will all the 3 switches will be on. So 1, 1, 1. And in binary, we start from the rightmost digit. I don't know if we call that this right or left. So we're going to start right here. So 2 to power 0. We start again. We always start counting from 0. So 0, and then this is 1, and this one is 2. So 2 to power 0 is 1. Any number to power 0 is 1, and 1 times 1 is 1. So we have 1 right there. Here we have a 1 at the top. So 2 to power 1 is 2. 2 times 1 is 2. And then here we have a 2. 2 to power 2 is 2. 2 to power 2 is 4. Sorry. And 4 times 1 is 4. And if we add all these, we get a 7. So if we want to represent a user as having, or any, be it a user, the group, or others, as we have covered up here, if you want them to have all the permissions, read, write, and execute, then we will provide the number 7, which basically means all the 3 switches are turned on. Some examples for better understanding, maybe if we have just the read and write permissions, then we are going to skip the last one, the 1, and you're going to focus on this one, which by now, of course, this one is a 2 and this one is a 4. If you add them, it's a 6. If we have the read and execute permissions, we're going to start with the X, which is a 1, skip the write, which is usually a 2, so we do not include that because it's not there. We jump to the read, which is represented by a 4. If we add that, it's a 5. If we do not have any permissions, of course, by default, it's a no-brainer. Just get a 0. So to alter the file permissions or to play around with them, first of all, to view them, I think you're already familiar with that. To view them, you just use the ls-l command. We already covered this yesterday, which is why I've not included that in my slides. But if you want to change or to alter the file permissions, we use something called the change mode command, or the change mode command line tool, and it allows us to change the file or directory permissions. So let's get to actually using it. So let me just use this file. Let me rename it from malware to maybe demo file. Let's do a long listing of that file. So as you can see, we, the owner of the file, only have read and write permissions. We do not have permissions to execute it. The group has only read permissions, and the other users have only the read permissions as well. So say, for instance, it's an executable that we have gotten from another system, or you've downloaded from the internet, and you would like to run it. If we try to run it, as you can see, we are told permission denied. And the reason for that is because we do not have the execute permission. So what we are going to do is use the change mode command, and then we are going to use these numeric values to specify the permissions that we want to assign. And again, we have 3 sets. So we have to provide all 3 sets. So we're going to provide the value for the user, for the group, and for the others. So we're going to start with the user. We want him to have all permissions. So that will be a 7, which means this will be updated to read, write, and execute. And then for the rest, you can just leave them as they are. So this is 4 and this is 4, 7, 4, 4, followed by the name of the file, hit enter. And if we do a long listing of the file again, you can see we now have an X value right here. And even the color now changes from white to green. So if the file is green in color, that means it is executable. And if you try to execute it, of course, it will do nothing because it's empty, but you will not get a permission denied. So I hope you understand that. Let's try playing around with it. So let me edit the file, add blah, 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 and then I'm going to save it. And then I want us to remove the read permission from it, and then we will try to display its contents and see if the system will allow us to do that. So again, I'm going to do change mode. We want to remove the read permission from it. So we will only have W and X. That is 1 plus 2, which is, 1 plus 2, which is 3. So 3, 4, 4, demo file, hit enter. If you do a long listing of the file, now we only have the write and execute. And so if we try to display its contents, which is reading the file, we should be denied that. As you can see, permission denied. Let us try now to remove the write permission and see if we will be allowed to edit the file. So change mode. So now all we want is to have the read and execute permissions. So that is 1 plus 4, which is 5. We can leave the others as they are. Demo file, hit enter. And then let us try to edit it. So nano demo file. And as you can see, it is opened, yes. But if you look at the bottom, we get a red themed error message. File demo file is unwritable. And the reason for that is because we do not have permissions to do that. So I hope you now understand how to play around with the file permissions. Of course, you can do the same for all the others. I've just left them as they are because, you know, there's no difference. If we are able to understand how to do it for the owner of the file, then you should be able to do the same for the group and the other users as well. Another way of doing it, if we are tired of having to remember all these numbers in our heads, we can just do change mode. Say, for instance, we want to, let's do a long listing of the file, long listing of demo file. Right now, we only have the read permission, but we do not have the write permission. So let's say we, for instance, want to just add the write permission. We already have read and execute. So rather than bothering ourselves with doing the, the calculations, we can just type in change mode. We want to change permissions for the user alone, and then we want to add. So use a plus. And which permission do we want to add? The write permission, and then the name of the file. So what this will do is that it will go to the demo file and alter its permissions for the user set by adding the write permissions. If we hit enter and do a long listing again, we now have the write permission turned on. So here it was not there, and now we have it. If you want to remove a permission, again, very simple. Instead of using a plus, just use a minus, hit enter, do a long listing again, and it has been removed. So I hope that is clear. Any questions? That's just about it for permissions. Of course, if you want to do the same for other permission sets, right now we focused on the user. If you want to do that for the group, let me try it for the group. So the group right here has only the read and only the read permissions. Let's say we want them to also be able to write to this file. We are going to focus on the group. Again, we use small letters, U for the user, G for the group, and O for the others. So in this case, we want to alter permissions for the group. So change mode, G for the group. We want to add execute permissions in the file, demo file, hit enter, do a long listing of it. And as you can see, we have the execute permission turned on. That is it for permissions, guys. And I'm going to give you a chance to ask any questions or seek clarification on that before we move on to our final section, which is bash scripting. What does the first dash represent? You mean this one, Felista? Directory. So the first character, when you do a long listing of any file, denotes the type of file. So it can be one of 3 values. It can be a dash, which means it is just a regular file, an original regular file. It can be the letter D, which signifies that that entry is a directory, as you can see right here. or it can be the letter L, which you do not have here. But in case you have it, that means that that entry is a shortcut file. So on Windows, I'm sure you've encountered shortcut files. Most applications when installed on Windows will create a shortcut on the desktop to make it easier for you to start it. So in like manner on Linux, we can have that, and they'll be represented with a letter L at the start. I hope that is clear. Okay, any other question before we move on to the final section? Okay, let us move on to the final section. Could you do a brief summary of that part again? Of what? The permissions or the first character? You can just unmute and specify or type.
The permissions.
Permissions.
Yes.
Okay, so there's three kinds of permissions: read, write, and execute. Read allows the user to view the contents of the file or directory. Write allows the user to modify the contents, and execute allows the user to execute the file, of course, if it is a program or script. And to change it or to play around with these permissions, we use the change mode command line utility. And again, we have two ways of doing that. We can either provide the numeric value that presents the permission set, or we can just use the letters. For instance, specify the kind of group or the permission set that you want to modify, and then use either a minus or a plus if you want to remove a permission or add a permission, respectively, followed by a letter denoting the permission type. You do not have to worry a lot about it. If you want to maybe go deeper into it, you can just feel free to look it up after the session. This is just the foundations. There's a lot more to it actually than just what we've covered. Slide 4. I hope you haven't joined late, because if you have, I'm not going to go back there. I'm sorry, I can't do that. Let me first finish the presentation. I can't go that much back. So a note on bash scripting. So bash is short for Born Again Shell, and it is a command line interpreter or shell for Linux-based systems. So all the commands that you've been executing so far, what happens behind the scenes is that they go through an engine. Please excuse me, guys, for a minute. Sorry for that, guys. I hope you can hear me. Please confirm.
Yeah, we can.
Okay. Sorry about the interruption. I had to attend to something urgent. So back to bash scripting. Bash, again, is short for the Born Again shell, and it is the interpreter behind all the things that you've been doing on the command line. So what happens behind the scenes when you type in, for instance, ls -l, is that this command is passed on to a sort of engine, quote unquote, which then calls the appropriate file. We said everything in Linux is a file, including these ls, change mode, they are all executable files. So the engine does is that it calls that file, and it passes, any parameters or arguments that you have provided, and then it gets back the result and gives it to us. Or if it's a particular task that is supposed to be done, it executes it and gives us any feedback if necessary. So we can extend the functionality of, or rather we can capitalize on this interpreter by chaining together more than one command and saving that as a file, which is what we call a bash script, okay? By the way, the Born Again shell, or what we call bash, is the default shell even on Mac OS. So if you are on Mac, that is why if you are on Mac, you can also execute more or less the same commands. These commands apply even on Mac OS, and that is because they share the same engine, so to speak. So bash scripting now involves putting together multiple commands. Of course, now you're familiar with a number of commands here and there. So if you want to do, you know, a series of tasks and you want to just for instance, be doing it repetitively, maybe every day, you want to do some sysadmin tasks, or you want to help out a beginner Linux user somewhere, you can just put together all these commands in a single file, which is what we call a bash script, and then share that with them. Or if it is for your own personal use, you can just save all these commands in the bash script, and then every day just execute one single file rather than having to type in all the commands all over again. So to create a bash script, all you need to do is to create a new file with a .sh extension. Okay, that is really important, with a .sh extension, and then add the commands that you want executed to it. Give it execute permissions. I hope by now you're aware of the fact that Linux is quite strict with permissions. So if you create a new file, for instance, test, and then you do a long listing of the file, it will by default not have the execute permissions. And so that's why it's important for us to give it the execute permissions. That is our bash script. Once we are done creating it and adding the commands to it, and then once we are done with that, we just execute it. And to execute it, to do a // which means we are running an executable file, followed by the name, which is, you know, the name that we've given it, followed by the extension, which is .sh. Now, this is an entire topic of its own, and that is why I've not, you know, dedicated like a few slides to it or something. All I've done is introduce you to what it entails. And so if you're interested in going deeper into bash scripting, feel free to get online and look up bash scripting. Let me just do that right here. There's a bash scripting tutorial. And you get a nice set of tutorials if you're a fan of YouTube, Zavati Point, FreeCodeCamp. So you can actually check this out. Let me open it and share the link with you. And by the way, bash scripting is not just limited to terminal commands. So again, as you've said, it's a command line interpreter. So it's a fully fledged interpreter. And so just as with any other programming language out there, we have other things like variable assignments. We can implement loops, and we can also implement things like conditionals in bash scripting. Again, that is the reason why I've not gone deeper into it, because it's really, really broad. Yeah, so feel free to check this one out. Let me just copy it and paste it right here. So Stella, I might look at it once we are done. Let me just finish up. So that's it, guys, for bash scripting. Any question on it, or any need for clarification on it? If you've understood, you can confirm with a thumbs up. Awesome, awesome.
Okay, I have a question.
Yes, go on.
It's concerning file permissions.
Uh-huh.
So if you want to maybe add more privileges, let's say for a user, and you don't want to use the numeric system. So let's say a file has only read permissions, but you want to use
the
letters.
Please come again, or you can try typing your question. I briefly lost you, so I haven't gotten your question.
Okay. Okay, let me repeat. So I'm saying if you want to change the file permissions of a certain file, and you don't want to use the numeric system, you want to use the letters. So let's say this particular file has only read permissions, and you want to add the write and execute permissions. So can you chain? Yeah, can you chain in one command line so that maybe it becomes chmod and then u plus w plus x?
Okay, let us try it. Actually, I've never tried it out. That's a great question. So let us try it out on this file test. So let's say, for instance, we want to add both the write and execute permissions to this to the others permission set right here in one go. So let's try it out together, because I've never done it before. So others, let's try plus read and execute for the file test. Hit enter. Let's do a long listing of it again. And it has worked. Yeah. So all you need to do is just change them. I hope that is clear.
Yeah, thank you.
Yeah, thank you as well. I didn't know about that. Any other question? Okay, if there's none, I can just do a quick run through of slide 4 for the sake of one of us. Let me go back to it. Okay, so on software and package management, I don't know why, if you were here when we were covering the slide, maybe you can just ask, you can maybe be more specific, because going through everything here will take quite a lot of time. Stella, do you have a specific part within this slide that you'd like clarified? Stella, are you there? Okay, this upgrade. Thank you for that. So this upgrade we said is closely related with the upgrade command. The only difference between apt-get upgrade and apt-get dist upgrade is that in the case of apt-get upgrade, the only thing that gets upgraded is the binary, the executable, the main executable. But apt-get dist upgrade is more caring and more intelligent, quote unquote, and it will go on to look at the dependency versions, the versions of dependencies for this particular binary, and upgrade them as well. So while upgrade is just limited to the main binary, this upgrade will upgrade, everything that is a part of that package. I hope that explains it. Is it clear now? Okay, thank you. Please allow me to just touch on something that we had covered yesterday. I was supposed to start with it, but I forgot. And if you can remember yesterday, there is 2 commands that we were unable to execute as expected. And one of them was the find command. I don't know if you can remember. We tried out the find command and it did not, list the file that you are providing to it. And I realized after the session that we are actually supposed to provide the complete name of the file. So in the other commands like find, in the other commands like locate or where is, we can provide just, for instance, the first few letters or something like that. But in the case of the find command, the reason it did not work is because we are required to provide the full name. So let us try it again. So it was find, we provide the name suite, and we type in the full name. As you can see, if I type Australia, as you can see, we get nothing, okay? But if we provide the complete name, .jpg, and hit enter, we get the file. So that was the problem. The other command that didn't work as was supposed to was the less command, where I was telling us the less command allows us to do a lot more, and it gives us more power and flexibility as compared to the more command. And one of the areas where it shines, as I had mentioned, was allowing us to search for occurrences of a particular text within a file, but it didn't work again. So I'm going to open the file that we had used for that. So we have the window opened. So we have the file right here. And what I was doing to search for occurrences of a particular piece of text was that I was starting with a backslash. But then again, on day 1, I am the same person that told us that one of the core differences between Linux and Windows is that on Linux we have forward slashes instead of backslashes. So where we were getting it wrong was I was using the backslash instead of forward slash. So the correct manner to do it is type in a forward slash. As you can see, it now appears. And I can look for example, the username root. And if I hit enter, it will highlight every occurrence of that particular piece of text. And if I want to keep going through the file looking for further occurrences, I can just type in the letter N. So that's what I'm doing right now. And as you can see, it goes through the file looking for occurrences of the file, and it keeps highlighting them. So that is where we had gone wrong yesterday for the command not to work as expected. That is it, guys. I am done for today's session. And if there is no more questions or need for clarifications, I'm going to hand it over to Felista. Yeah, so tomorrow we'll touch on Kali Linux, and if we'll have an opportunity, maybe even have a short demo where we will see Kali Linux in action, maybe being used in a hack or doing some forensics. That's what we'll be doing tomorrow.
Yeah, I'd just like to thank Nemal for the session. It was very comprehensive and thorough.
Mine is just to appreciate Nemo for the great work he's doing. We met some time back ago, and it's good to see him growing well. And the knowledge he has is very, very, very insightful. So, asante sana Nemo. Mm.